All right, guys, here's the momentum test review. It might go kind of quick. What's the velocity of an object with a mass of 21.3 and a momentum of 8,734.3? So you just say 8,734.3 P equals 21.3 at blank meters per second. So 834.3 divided by 21.3 gives us 410 meters per second. Okay, I don't know why those announcements are 22 minutes early, but whatever. What is the mass of an object? It has a velocity of 73.5 meters per second, and the P is 1.78. The mass must be pretty low, right? Kilograms times meters per second. So this was just 1.78 divided by 73.5 meters per second gives us 0.024 meters per second. What is the impulse of an object with a force of 26 and a time of 2.5? Impulse is equal to force times change in time. 26 times 2.5. 26 times 2.5. 65. 65 Newton seconds. A lever pushes on a 22 kilogram box. It pushes with 200 newtons for 1.5 seconds. How much will the velocity of the box increase? Right, force times the change in time equals mass times the change in velocity. So 200 times 1.5 divided by 22 equals 13.6. 13.6. That would really increase the velocity, wouldn't it? 25 kilogram ball bounces off a wall. Okay, here's the wall. We've got 25 kilograms going that way. Okay, at 2.3 meters per second. So originally we have 25 times 2.3 equals 57.5 P to the right. After it bounces off the wall, it's going the other way at 2.29 meters per second. So now we're going backwards at 2.29 meters per second. So we're going 25 times 2.29 equals, now we have 57.25 the opposite way. Well, if this is positive, we got to say this is negative. So how far are these things apart? Very far apart. The change in momentum is equal to 114.75 P. You have to add those two together because they're going in two different directions, all right? If the impact lasted 0.25 seconds, what force was applied? Force times change in time equals change in momentum. This is impulse. So the change in time was 0.25 seconds, and the change in momentum was 114.75. So the force would be equal to 114.75 divided by 0.25. 114.75 divided by 0.25. 459 newtons of force. Okay, let's keep rolling. 2,000 kilogram northbound car at 14 meters per second. 2,000 kilograms at 14 meters per second is heading north. A 3,000 kilogram eastbound truck at 12. 3,000 at 12 meters per second. So this way we have 36,000 P. This way up we have 28,000 P. So this line is a little bit longer than this line. Does that make sense to everyone? So when we go up, we're going to go more left than right. Everybody agree with more left than up? So we're going to take this 36,000 and we're going to make it right there. 36,000 P. And we're going to keep our 28,000 was in the up. 28,000 P. Now these two things stick together and they go flying away. Well, let's figure out how much momentum they have. 28,000 squared plus 36,000 squared equals square root. 45,607 P. 45,607 P. That's the total momentum in that direction, okay? Now, we have 45,607 P, and both of these cars have stuck together, so they weigh 5,000 kilograms, and their new velocity is this. 45,000 divided by 5,000 kilograms gives us 9.1 meters per second. Good. Now, what angle did they fly away with? Well, we know the opposite and the adjacent, so I'm just going to say the tangent of theta, of this angle, is equal to 36,000 divided by 28,000. 36 divided by 28 equals second tangent. 52 degrees. Now this is 52 degrees off of north. If north is 360, then we'd say 360 minus 52 degrees. 308 degrees is our new heading, and 9.1 meters per second is our new velocity. All right? An Atwood machine has two masses. 300 and 310. So here we go. 300 on one side, kilograms. 310 on the other side. That's the side that's going to go down. Acceleration on an Atwood machine on Earth is gravity times the difference in the masses, 310 minus 300, over the sum of the masses, 610. So this is going to be gravity times 10, or that's going to be 98. 98 divided by 610. That gives us 0.16 meters per second. And that looks right, because it will go very slowly. These things are both very heavy. All right, that's how elevator works, right? We got one last problem left here. Two 9-kilogram bowling balls are rolling in the same direction. All right. The one in the back is going 4 meters per second. This one's going 3 meters per second. So we have 36p plus 27p, and that gives us, God, what is wrong with my brain? 63p to the right. There's our total p. Okay, I know I'm going fast, but you know we've been doing this a lot. After the collision, the one in front, the 9-kilogram guy, he's now going 3.5. So he's got 9 times 3.5. He's got 31.5 p. So the rest of this 63p is going to go to the other bowling ball. It's all still rolling the other 9-kilogram bowling ball. Let's see. The difference in those two is 31.5. 31.5p. So he's now going to be going 3.5 meters per second also. They're going to be going the same velocity. Now, is this completely inelastic? Here's what we'd have to do. We'd have to add up the kinetic energy of this guy. Kinetic energy of this guy is 1/2 mv squared, so that's going to be 2. Oh, Lord, that's going to be 4.5 times 16, right? 4.5 times 16 equals 72 joules of kinetic energy, and this guy's going to be 1/2 9 times 9, because that's 3 squared, 4.5 times 9, 40.5 joules. Add these two guys up, plus 72, 112.5 joules total. 112.5 joules total. So let's see if that's how many joules of energy we have here. At the end, we have 1/2 9 times 3.5 squared, okay? 0.5 times 9 times 3.5 squared equals 55.125. And this guy would also have 55.125, so we'll add those up, times 2, 110.25. So it's not quite the same. It's not a perfect reaction. I hope you enjoyed this.